Hi, I'm Isa. Please call me Isa. Isabella feels too long. And I'm here to talk about fast websites, performance, and more specifically with a thing called memoization. Don't feel bad if you don't know it. I am going to explain what it is. But first, I would like to share with you something really freaky that happened to me when I got to Bern. I'm sure you guys know this place, right? Are you all from Bern? Or some of you? Cool. It's a huge clock. And I have never been to Switzerland, but imagine my surprise when I bumped into this. I had this really strange feeling like, I have been here before. This is so weird. And I just sat there for like, I don't know, 1 or 2 minutes trying to figure out where do I know this shit from. And turns out, when I was a kid, like about 4 or 5 years old, I did a puzzle that is this fucking place. And that was the craziest feeling of, wow, I know this place and I've never been here. It's quite old. Like, this is a box. It's from, well, I'm Brazilian, so it's all in Portuguese, but basically it says, like, countries, Suiza, which is Switzerland. But yeah, that was crazy. So thank you so much for having me, Bern. I love this city already. So yeah, back to the topic of the talk. Who likes watching this? Who wakes up in the morning and says, wow, I just want to like watch some websites load, I just want to watch some spinners load. Cool. Yeah, nobody, except, yeah. But there was this research, which is very interesting, and basically they concluded that the amount of stress that you get from waiting for web content to load is proportional to the same thing that you get when you watch a horror film or when you have a discussion with your partner. So yeah, sounds horrible, and it really is. But the ways we have to solve it is like by inlining the critical CSS. The critical CSS is that one, the styling that we do for the content above the fold of the website. The fold is like that part that gets rendered, that gets loaded first. It's the first thing the users see before they scroll. We could do that. Inlining CSS makes it faster, makes it render faster, or at least gives it the impression that it's, wow, going really fast. Or we could also gzip, which is a kind of a buzzwordy the last few years, which is like having this very effective way of compressing the websites. We could also do code splitting, which is a topic of Sean's talk. I really recommend you watching it, which is basically just serving the exact amount of code that you need for your website to run in a certain page or module. There's uglification and font subsetting, which is like getting the exact fonts that you're going to use. For instance, if you're only going to use like uppercase letters, you can just have that file. You don't need the rest of the web font. But what about this bitch? What do we feel like when we get this kind of error? Like, yeah, because our functions may sometimes not be very optimized, or they may have some faulty things going on inside it, and then all the rest of the performance things that we just did go down the drain. So if we think about our code or like some project that we're doing, the tiny cells in that thing are the functions, and we really have to look after how are they actually performing. That is a very interesting and important part of our project. And we can make them faster by using something called memoization. And don't worry if you don't know, but can anybody tell me how much is 7 times 7? Seriously, anyone? 49. Thank you. How did you get to the result of 49? Did you calculate it like 7 plus 7 equals 14? Okay, plus 7, 21. Or did you remember? You remember this, right? This is memoization. It's the thing that you do in your function when you have this very repetitive calculation, and you know that you're going to have to return the same result when you pass the same parameters. Instead of calculating them every single time, you're just going to return this thing that you've already cached. This is pretty much it. Now you know. I'm Isa, and this is my real talent. It's not talking or conferencing or coding. I am a Mozilla Tech speaker. We have a couple of us right now. Yay! And I also work at iZettle making code. And iZettle, for those of you who don't know, it's like some sort of platform that enables very tiny merchants, a lot of people that have like micro businesses to get paid, to get their lives going. So that's pretty cool. And I'm also Brazilian and karaoke star and Sean's camera person when he jumps on rivers. So cool. Why should we care about fast websites? Like, is that just something that we'd like to add as a nice feature? Why is it even important? Well, nowadays, like 53% of all internet access is made through mobile connections, and only 47. This is the first time ever since 2018, that mobile is surpassing traditional computer connections. And that means when we have like smartphones, we're often like relying on internet, like mobile internet, 4G, 3G. That often means that we're getting like a subversion of what a website can actually be. In China, that's even more impressive because 98% of all accesses are made through mobile connections. And it is kind of concerning because if we take a look around, we see that on average, the speed is not super good. Like we see, obviously, here in Europe and the US, also Australia, it can get quite good. That's nice because usually, well, that's a very developed country. So you get a lot more people that can afford like expensive data plans. And that's pretty cool. We have a lot more infrastructure also to provide like fast connections. But on developing countries such as like most of the South America, some countries in Asia, and Africa, that is not quite the case. Like we have very slow and also sometimes defective connections, and that's kind of a problem. So nowadays, 60% of mobile connections are 2G, and not even because like, oh, you're probably in Africa, you're probably in South America. Sometimes because like you have bad Wi-Fi, you have roaming, internet roaming. When you usually like get out of a country, they give you free data, but it's 2G, so it's like you're stuck in this nightmare, you know. So yeah, it's not common sense that we have good internet all the time. And nowadays, the web has also changed. Like if we take a look at 2011, we see that the websites were much, much smaller in terms of like how much we serve or how many scripts we load when we compare with like 2017. And that number probably also changed. I couldn't get like a more recent statistics, but it's like quite a lot bigger. Like it has tripled in size. And the web was supposed to be for everyone, and that means because like nowadays we have so many things going on through the internet. We have like tax declaration things are usually online throughout most countries, and like very important tasks that we have to do nowadays are very reliant on connections and internet and speed and rendering. And it kind of sucks for us to think that, well, when we don't make our websites fast enough, that could be us limiting access of information to someone else that don't have the same opportunities or privileges as us. So this kind of sucks. But cool, how do we fix it? It's not totally apocalyptic talk, don't worry. There is kind of some lights in the end of the tunnel. We could do all of these things that I just showed before, and we can also do memoization. But okay, what is it really? Like if we're trying to give like a formal definition for, oh, memoization, what is this? Basically, it's just like caching function results and instead of calculating them every time. So that kind of implies that you have to have like a deterministic function, which is basically a function that all the times that you pass the same parameters, they are 100% of the time going to return the same result for you. And this is important because like if you have something interfering with that, like application state or some API call, you could either be returning like a wrong result, or you could be skipping a very important calculation that you have to do that doesn't necessarily affect the result, but will affect your application later on. So it's very important that your function is deterministic. And it's basically us saying that in this case, for this function, I prefer to prioritize the computation speed, meaning that I'm going to suffer a little bit on the part of the memory. And also, it's always up to you, like how much you want to favor one over the other. But in these cases where you have more memory space in your application or your server or whatever, you can always have some sort of like drawback in favor the computation speed, which in a lot of sense makes in a lot of cases makes a lot of sense. Cool. So I'm gonna show you what it is by doing. It's gonna be nice, hopefully. Demo gods, help me. Cool. So is this pretty small, right? Can you guys see it now? Is it? No. Jesus Christ. Okay, cool. Yes. Great. Yeah. Okay, cool. So I feel like I'm typing in like some sort of computer for blind people. It's great. Cool. So I'm gonna show you in some sort of like pseudocode what it is really that we have to do, and then we'll go on to more meaningful real life examples. So basically, we're just gonna instantiate a function called, I don't know, expensive func, and it's gonna have some arguments. The first thing we have to do is check if we already have a cache for that function instantiated. We can think of the cache as like some regular object. So let's check if we don't already have this expensive function cache, we instantiate it. Cool. So now we have it. And then we can move on to actually checking if we have an entry with that argument already in our cache. So if we already have the thing in the cache, return it. And obviously there is a lot of better ways of doing this, but I'm making this very easy to understand. So return this thing. Otherwise, we allocate that result from those arguments in the cache and return it. So we're going to have that equals to, I don't know, some expensive operation. Oh, this is, yeah, this sucks. Can you see it now? Cool. So this is pretty much how every Memoize function will look like. This is like the prototype of how we're actually going to do that in the real world. Cool. So let's do something more meaningful now. Also, not super meaningful because it's hard to guess every example that you may have or may encounter in your actual lives. But let's say that we have some sort of e-commerce thingy and we have this coupon code for spring sale. I don't know. So let's make a function to calculate discounts over the price of an item. So function calculate discount. It's gonna receive, I don't know, the item price. And we do the exact same thing, but considering the operation that we're gonna have. So we can just set the discount on a constant, saying discount is gonna equal, I don't know, 25%. Sounds like the discount, right? Cool. So we're gonna do the exact same thing. We're gonna check if we already have the cache instantiated. So calculate discount.cache. If that's not a thing, we make it into a thing. Cool. Now we check if we already have that in the cache. Otherwise, we return it. Yeah. Item price. Cool. Return this thingy. Otherwise, we store in a cache and return it. So return, let's say it's going to be item price minus the discounted thing. Cool. So that's a memoized calculate discount function. And we can, well, let's see how long it takes to run non-memoized versus memoized. So a very good way of doing this, by the way, if you don't know how to track how much time your function is taking to run, you can do something called console time. Add a title to it. It's kind of like the label that you're going to recognize it with. So since this is going to be the first call that we're calling this function, it's going to be non-memoized call. Cool. Let's console log the result of calculate discount, saying, I don't know, 400 monies. And we add exactly the same thing, but time end for saying, yeah, this has ran. Oh shit, no, I called it untitled. Yeah, whatever. I have no idea where I save this. Wow. Cool, so let's see. This is super small, right? Okay, we have untitled. Cool. So Let's run this thing. Okay, so we're taking 2.2 milliseconds to run this. Let's see how much it takes for the Memoize call. It's going to be the same thing, but we're going to call it twice because that's when we're caching it. So 600. I don't know. Cool. Can you guys see it? Is it fine? Okay, cool. So for the first time, we took like 2 milliseconds to run this thing, and because we memoized and cached the results, we're only take like 0.117, which is crazy. I mean, in the world of milliseconds, it's fine, but like think about an actual function. So yeah, one thing that I always like to do, because I'm such a math freak, I like to calculate exactly how much time am I saving. So we can do that right now. So 11.7 over 2,196. Did I do this right? Cool. So we only took 5% of the time to calculate the Memoize one, which is pretty cool. We have a 95% increase in performance in this this function case. Awesome. Cool. But we don't want to do the same thing all the time, right? We just want to do like a generic thing that will memoize all our functions. Like we can think of it like a wrapper function or something. Cool. So let's do that. I'm going to delete all of this and we can get back at it later. So I'm going to turn this memoize calculate discount function into just a normal calculate discount. So I'm going to take away all the memoization thingies. And just do the operation. Cool, now we have it. So if we were to make a generalized thing, we can make like a general memoized function that takes like another function as parameter, because that's how we're going to do it. And that's going to return another function that will do everything for us. So basically, the first thing that we have to do in this case is to split all the params away from this thing, because we want to exactly pass that to our function within the scope. So we can say just like args, we're gonna slice them for the type slice call in the arguments, which is a reserved word for all the arguments that you're getting on the function from the parameter. And now we, just like before, we're going to do this checking if we already have the cache in place. Otherwise, we're going to allocate it. So let's say func cache. If it's not a thing, it's going to either be itself or a empty object. Cool. So now the only thing we need to do now is the exact same thing that we were doing before. So return either the function, oh my god, cache, with the arguments that we had, if that's a thing. Otherwise, we will just allocate it in the cache and return it. So func cache args will equal whatever our function was doing in the first place. We can't really predict that, so we're just going to call it for real. So function apply. Here I'm using apply because call only works if you have like one argument, and apply works for several. And since in this case we don't know how many arguments the user is passing, it's more of a safe bet. So for this we need to pass this, which is the scope thingy, and all the arguments that we have in place. Cool. What am I missing here? So we have demo gods help me. Cool. Where? No.
Around the assignment on the left hand and on the right hand.
Where? Sorry?
Before func.cache, where you say
Before.
line 25 after the or.
Yeah. Oh, right. Thank you. Yeah. What the fuck? Yeah. Right. Perfect. So there we go. That's our Memoize. Thank you so much, by the way. That's our Memoize generic function. Great. And now we can just like say that we have. This is coming back to be just a normal function, by the way. So we can just wrap it around the generic Memoize one. So let's say memoized discount calculation. I don't know. will equal memoized and the what is the name? Calculate discount. Cool. So now every time that we call this function that we just declared here, it's going to be the memoized version of a normal one, which is really nice because it gives you the flexibility of just being able to apply that to absolutely everything in your code. Like you don't need to repeat these same steps of like checking, do we have a cache? Otherwise, return this. Because we can just like add it and be able to move on with our lives. Cool. So let's do the same computation. Console time not memoized call. Then we do the function with, I don't know, 1,000. We're feeling rich now. So console time end not memoized. And we're going to repeat the same thing with the same value to see how much time we're actually spending on the memoized one. Cool. So let's run this. And again, we are taking a lot less time. This time we took less because we're doing it with a wrapper, so it's more optimized underlying. But we are only take like 0.45 milliseconds, and the other one we're taking like a lot less than that, which is pretty cool. So that's very flexible. You can use that in absolutely everything. You can even like do it yourself. It's very straightforward. And yeah, so I'm gonna continue the talk now. Cool. Great. So now we see how to do it. We see how that changes our code and like the performance improvements and all that. So that's pretty cool. And I must warn you, it's a lot better to use this in pure functions, exactly because if you have something that will interfere, or if you have some like effect, something that is happening because of that function, or you have like two responsibilities in the same function, maybe by caching that, you're not going to have exactly what you need or what you're looking for. So it's always nice to just have that being applied for pure functions and deterministic functions. And it's even better if you have like a recursive function, because when we think about recursion, it's basically like, sorry, I'm not going to make you look at this for too long. But yeah, look at Fibonacci, for instance. A recursive function is basically a function that will call itself multiple times and search for the previous, or like in this case, the previous and the other one before that. You're gonna look for this result quite a lot of times. So it makes a lot of sense for you to cache this thing, because you're gonna take like a lot less time to compute everything. So if we see at the whole call stack, we can see like Fibonacci with a parameter of 4. That happens in a lot of places. So if we don't have to calculate that all the time, or if we don't have to call the other functions again, that's going to be a lot faster. So that's a pretty cool idea to use that in recursive functions. And I'm aware that you guys are mostly like Angular people. How many people here use React? Oh, awesome. 50-50-ish. Nice. And I'm not sure if you guys know, but in this last release from React, there's a thing called React hooks. It's all over Twitter. And they have one of the hooks, which is like use memo, which is basically this thing that we have just done, but implemented within the whole React ecosystem, which is pretty cool. You guys should definitely check it out. It pretty much works kind of very similar to what we just did. You're going to have like a non-memoized function, and you only want to execute it again in case props A or B change. And for that, you can just wrap it around this function called useMemo, and there you go. It's a memoized function. It's pretty cool, especially when we're thinking about rendering and like something that calls maybe the set state. Nowadays, like the use state hook. If you're calling that quite a lot of times, and perhaps you don't need to call them all the time because the props aren't actually changing, it could be a good idea to just memoize that. It's pretty nice. You guys should check it out. So great, we are now professional memoizators. It sounds horrible, but now we know a lot more about web performance and how to make our functions run faster, possibly more smoothly. That's pretty cool. But the key takeaways that I want to leave here right now are that, well, memoization is a great tool for expensive operators. Maybe it don't make sense to memorize all the things, because then you could be potentially like screwing up your memory over a function that isn't even all that expensive. So it takes a lot of like analysis of your own code base, or even debugging, because like one thing that I do quite a lot of talks on performance, and the one thing that I always say is like, don't just start optimizing everything if you don't actually know what's your bottleneck. So memoization is a really good technique or tool to, if you have like very expensive functions that are taking a lot of time to run, and they are like called multiple times with the same arguments perhaps. So it is a really good tool for that. But always in performance, don't just like optimize all the things when you don't actually know if there's actually a problem with your application. Like obviously, it's a nice thing to have a couple of good practices in place. Like don't push that many uncompressed code to the application. That's always nice. But for memoization, for instance, it's something that could affect the performance of your application if that's not a problem. So it's really nice. You're probably going to have to use it a couple of times, but take some thoughts and think like, is this even for me? And the other thing is like, performance is not an issue. It's not a feature. Like it's not something that okay, making the website just work is like it's half of the work really, because as I said, like if your website is not performant enough, it's not fast enough, maybe a couple of times we're just limiting how much access someone that could be actually very much in need of your website, or like that is very true for websites that are for education. So it is a very big thing if you're not providing them a good experience, because sometimes that could be meaning that like, a richer person is getting like more of an advantage at life than other people, and that's not cool. So performance is really not a feature. Think about performance ever since the start of the project. It's going to be a lot easier for you then to like not have to refactor a bunch of things. Like just do very simple tweaks, like make functions decoupled, because that's going to be easier to test and to optimize if you need optimization. There is a bunch of things that we have to keep in mind way before actually delivering or handing off a project if you work as like an agency or something. And the most important thing is that it's up to us, we are software developers. We have to make sure that the web is still meant for everyone and that everybody can use the same things in the same proportion, because otherwise we are going to have like websites that only render on Chrome, or websites that only render if you have like a blazing fast connection. And well, maybe that's going to be a drawback for you, like if you have that case where you're in an airport and have shitty Wi-Fi. I have actually done that experiment quite a lot of times. Like I put some throttling in my connection to make, okay, what is this like if I was accessing in a 2G? And it's horrible. Like, don't do it. Don't make slow websites, because it's really dreadful. But it is very important for us to think that this is our responsibility too. So making things work is just really half the way that you have to go. And that's it. Danke. Merci. Grazie. You have a lot of languages, and there's like a secret fourth one that I have no idea how to say. Thank you so much. I hope you liked it.